So we will. Hey, Eddie, come on in. So 12 plus 2 is 14. 14 minus 5 is 9. So that'll eliminate our parentheses, and then we'll just bring everything down, and then, right, we just work left to right, multiplying first and then subtracting, so I get 62. Does that sound good for everyone for number 14? Oh. 9 times 7 minus 162. Eddie, we're just working off of paper right now. Do you have a notebook or paper? If not, I have some up here. You can use. But hopefully the hiccups are gone now that my belly's full. So that's important. Always that hour just flies. Flies. Okay. So number 15, right? We have 2 sets of parentheses to deal with. Now, hopefully everyone noticed here, right? 5 minus 1 is 4, right? So we really just have 7/4. You know, 7 doesn't evenly divide into 4. So I guess we can just kind of leave that fraction like that for now, and then let's see what else we've got. So then times 8 times 2. Okay. So remember, when you have multiplying, you have to start from left to right. Okay. So let's see, 7/4 times 8 is, well, actually here, let's just make this. So, right, we can cross reduce. Does everyone know what I'm doing here? So if I'm multiplying 2 fractions, I can look at the cross products and reduce if I can. So if I have a 4 down here and an 8 up here, right, I can take a 4 out of here and an 8 out of, or a 4 out of here and a 4 out of here, which reduces my 4 to a 1 and my 8 to a 2. Does everyone see that step? Like I said, that will just make it easier to do the math, right? Because now I have 7 times 2 is 14. 14 times 2 is 28. You guys get 28 for number 15? Yeah. Good. Good. Yeah, and I mean, it would still work if you did.
I did 1.75 times 8 times 2.
Yep, that's fine too, right? So when you actually do this division, like Kaylee's saying, you would get a fraction or a decimal, excuse me. Yeah, so 7 divided by 4 gives us 1.75, and then yeah, you can still just keep multiplying times 8 times 2 and do the same thing. So always good to think about your multiple routes to the end, and then like if you did 7 times 8 times 2 divided by 4, you should get 28 also. So yeah, there's lots of ways to get to the answer. Okay, so number 16, right? We have parentheses within parentheses, so we're always going to the innermost, right? Parentheses first to do our work. So 10 minus 8 is 2, right? And then 4 minus 2 is 2. So then the answer is 10. Yeah. Woo, woo, woo. Okay. So does anyone remember what this is called? It doesn't matter if you remember what it's called, but if anyone does, but hopefully everyone knows what to do, right? This is called the distributive property. So when we have a number hanging out on the edge of our parentheses, we know that we have to multiply each term inside by 4. And that's going to be our first step here. So 4 times 5 is 20. 4 times -4 is -16. Okay. And once again, right, before I can do any dividing, I still need to simplify my denominator, so 20 minus 16 is 4. 4 minus 1 is, or 4 minus 3 is 1, sorry. So we end up with 50 over 1 or 50.
Oh, I'm still.
How'd you guys do it differently than me?
I did the same thing. I just did 4 times 5 minus 4.
I don't even know. I just did 5 minus 4 and then did 4.
I guess that kind of, yeah, I mean, that works too, yeah. What did I, oh, I did the distribution, so yeah, that works too, fine, yeah, 5 minus 4 is 1. 1 times 4 is 4, 4 minus 3 is, yep, you guys are fine. Yep, so you could have done that step too, but I guess I just saw that hanging out there, so I figured. All right, how are you on Zoom feeling about order of operations? Have we beat the dead horse? Everyone feel good about these questions? Like I said, this is definitely one of the ones where, yeah, definitely GED style. No calculator allowed problems. Okay. Awesome. All right. One more bit of warm up, just because I want to make sure we're good. All right. All right, just to practice, let's do just work with, man, it's not gonna fit. Okay, well, you guys will work with that. So just work with these 5 equations here, okay? 2-step equations, solve for the variable, okay? Uh-oh.
When you put a square on G, you kind of blow it up. So
Let me see if I can make it a little bigger. Is that better, Eddie? That's as big as I can make it. Okay, but now they can't see all the problems. So let me know when you've got those 4 copied down, okay?
2, 5.
Yeah. I know, that's a problem when it gets all vertical like that. So remember that here you're kind of doing the order of operations backward, right? So you're always doing the inverse operation. Move this up just a little bit so everyone can see number 6 too. Hopefully everyone got number 2 written down. 8m plus 11 equals 43. Okay. And then let me know when you have your solutions for these 4 or 5 equations. Sure. Yeah. We can do. I'll do a harder one. Number 6. So 7/4 x, right? 7/4 times x minus 9 equals 26. So remember that we start with any adding or subtracting first, because now we're solving equations. We're kind of doing the opposite of the order, the inverse order of operations. So if this is minus 9, right? I need to add 9 to both sides of my equation, right? Minus 9 plus 9 is 0. So basically like cancels out. So I bring down what's left over, 7/4 x. 26 plus 9 is 35. Okay. Does anyone remember how to undo the fractions that are stuck onto our variable? This is where we use the reciprocal, right? So I take 7/4 and I flip it. And I multiply both sides of the equation by 4/7. Okay, right? These cancel down to 1, right? 4 times 7 is 28. 7 times 4 is 28. 28 over 28 is 1. So I just have 1x or x left over. Okay. Then, just like I showed you in the previous one, right? I can cross reduce, right? I can take a 7 out of here and a 7 out of here. 7 divided by 7 is 1. 35 divided by 7 is 5. 5 times 4 is. Does that help remind you what to do, Kaylee?
Yes, thank you.
All right, go ahead and try those other 4. So always, right, always start with whatever's being added or subtracted. Add or subtract from both sides, and then you look at, right, your, is x being multiplied or is it being divided, right? We look at problems 3 and 4, right, our variables are being divided. In problems 2 and 5, right, it's being multiplied. So if it's being divided, then you multiply by 3. If it's being multiplied then by 8, then you divide by 8. Where's my mouse? Goodness gracious. Oh, sorry. Oh. Huh? For number. Did I copy one down? Just making sure all you folks on Zoom have signed in. I'll let you guys work. I'll be right back.
It's like, oh, maybe I'll just be, oh, I did it 1:30. Number 4, stay.
How's it going?
Good.
Still working, finish? Hi Curtis, glad you could join us. Let's see. Okay, cool. Curtis, I'm gonna put a link in the chat. I need you to fill out this form. So click on the link, okay? This is how I keep track of your class attendance, so it's really important that you do this extra new step. If you have questions, maybe you can ask Shannon or Jessica, and I can explain to them what you need to do, but just so you know. Okay. Anyone want or need more time on these 5 problems? Okay, that's all right. I know some of you guys are just, diving in for the first time today, so it's a little overwhelming, but like I said, I want to make sure that this stuff makes sense because before we pile any more complexity onto what we're doing. Okay. So as we talked about, right, so we have our equation, 8m plus 11 equals 43. So we start right with whatever's being added or subtracted, so that's our first step. The opposite of adding is subtracting, so I need to subtract 11 from both sides of the equation. Okay, everyone hopefully remembers anything that happens on one side of the equal sign has to happen on the other side. Plus 11 minus 11 is 0, so that cancels out. So I'm going to bring down what's left over, which is my 8m. Okay, equals 43 minus 11 is 32. Okay, since this is 8 times m, the opposite of multiplying is dividing. So I'm going to divide both sides by 8. 8 divided by 8 is 1, or 1m. 32 divided by 8 is 4. So m equals 8. Good. Remember, whenever you get your answer, right, you can check it by plugging it in, right? If we put 4 here for m, right? 8 times 4 is 32. 32 plus 11 is 43. It makes a true statement, so our answer is for sure correct. Okay.
Do we have to learn it this way? Like, what if we got the right answer a completely different way?
That is perfectly fine with me. I am not a trained math teacher, so as much as I am aware that there are other ways to solve these equations, I'm not very good at teaching a variety of strategies. So yeah, if you have a way and it's working, fine with me. I might not be able to help you if you're not getting it right, but I can certainly try. How are you doing it, Caitlin? Or Kaylee, sorry. My niece,
Yeah, I didn't do the fraction part.
Oh,
I
the
just did
dividing part?
8 times 32. I mean, 8 divided by 32.
Yeah,
That's all I did.
okay. Okay. So you're still doing the subtract 11 step and the dividing by 8 step, but the like
Yeah,
canceling steps, you're okay. Yeah, and I mean, I'm just doing that hopefully to help everyone. So yeah, some people don't need to see that.
okay.
Yeah. It's just, yeah, mostly like visual support. Because yeah, for other folks who aren't as familiar with algebra, sometimes this can be overwhelming. So hopefully this at least kind of gives the why. If you can't just kind of see it without having to see it. So yeah, not a big deal. All right, so number 3, right? We're gonna subtract 4 from both sides. Right, so plus 4 minus 4 is 0. So x over 5, or x divided by 5 equals 7 minus 4 is 3. So hopefully everyone's remembering this is x divided by 5. So the opposite would be right to multiply by 5. So I'm just going to multiply both sides by 5. If you're super smart like Kaylee, you might not need to see that step, right? But 5 times x over 5 leaves us with x. 3 times 5 is 15. So x equals 15. Okay.
So can we replace x with 1?
No.
No.
You mean if x equals 1, or what are you saying?
No, like you have x over 5. Would we do 1 over 5?
Like 1/5 x?
No. Like, just 1/5 and then do it that way. Because that's how I did it and I got 15 still. Does that work? Or-
1/5 plus 4 equals 7.
No, I don't know how I did it.
Well, I mean, getting the right answer is what's important. I guess for me, like, x is the variable, right? So I have no idea what x equals until I deal with the other numbers in the equation, right? So I would be very nervous, like just guessing numbers to fill in here to see what works.
Okay, I was just wondering because doesn't 1 times anything equals the same? Like 1 times x would equal x.
Yeah. I mean, there's always like an invisible 1 here too, right? Next to the x. So there's always kind of a 1 with your variable. Because you always set that as one of it. But, I mean, yeah, yeah, as long as you know, like, you know, just as long as you know that X is being divided and not multiplied, added, or subtracted, right? And then to know that the opposite is to multiply is hopefully the principle there. As far as the avenue, the path that you take, there's probably multiple paths. So yeah, hopefully that method keeps working out. So number 4, right? So we've got -1, so we should add 1 to both sides. So 7.5 equals D over 3. 3 times 7.5 is, what? 7.5? Times 3 is 7.5
times.
Oh, right, because it's Z divided by 3. So then I need to multiply both sides by 3. Right? That's a Z. Oh, yeah, that's gonna make a difference. Z divided by 3 minus 1 equals 6.5. So then we gotta add 1 to both sides and then multiply both sides by 3. So Z equals 22.5. See where you got a little hiccup? All right, and then finally, number 5, right, we're gonna subtract 7 from both sides is our first step. 16 minus 7 is 9. So 3/4 X equals 9. So we take our reciprocal, right? We flip it. So then we have to multiply both sides by 4/3. Okay. So that's gonna cancel X equals 12. Right, because I can take a 3 out of here, I can take a 3 out of here, yeah. Any questions or comments about two-step equations? Is everyone feeling good about these? Everyone's feeling quiet about them? Okay, Melissa, thanks. Okay, cool. So hopefully everyone feels like you've got these 2 pieces down. And there's no questions. Let me know if I'm going too fast. Or if I should go faster. On the way. All right, good. Okay. Next. All right, little bit more warm up. Just to give you guys a little bit more practice, because of course this is probably the way that we'll have to deal with two-step equations is as word problems. So we've got 3 word problems here. So you need to identify what is the variable, what don't we know? Based on the information we do know, you set up an equation, right? A two-step equation like we talked about. And then, right, by solving the equation for the variable, you should get a solution, okay?
Salud.
How's everyone doing? All right, let's go ahead and talk about these ones. How did they go? Pretty swell. Okay. Wendy has a part-time job. Each month, Wendy deposited 1/10 of her check in a savings account. After 6 deposits, she placed an additional $150 in this account. If she now has $900 in savings, how much does Wendy usually deposit each month? Okay, so of course, right? Our variable, right, is gonna be in dollars, right? Okay. So when we think about the equation, did anyone get an equation written to help solve this one? What's the solution? Okay. So she deposits 1/10 of her check. And we're doing it after 6 deposits, right? So it's 6 deposits of 1/10, right? And then an additional $150. So that now, right, after this and this, right, the total is 900. So right. Does this equation make sense? Hopefully. That's okay. Did you get the answer? What's the answer?
I got 125.
Okay, how'd you get it?
I just did like 900 minus the 150.
Mhm.
And then I just did, that was 750 and I was divided by 6.
Yeah. Sorry, I totally messed up, yep. Sorry, so take this part away. So 6 deposits plus another $150 gives us $900. So, yeah, so you don't have to make it into an equation, it's just. Yeah, so you can definitely reason these ones out too, don't feel like you have to use an equation, but yes, the answer is 125. Right, so 900 minus 150 divided by 6. So wow, she's making a 1250 a month. Okay. All right, let's look at number 5 then. At Hoover Elementary School, 60% of the students are in the grades kindergarten through 3rd grade. If 180 children are in these 4 grades, what is the total enrollment at Hoover Elementary? So hopefully everyone figured out, right, the variable or what we don't know, right, is school total enrollment. Okay, but we do know, right, that 60%, right, of the, I guess we'll just say T, right, equals 180. So what do we need to do to figure this one out? Right, 60% of the total elementary school population is 180. So what's the total?
432.
432? How'd you get that?
I never said 60. So, I'm like, I just did 60% times 180, which is 108, and then I think it is times 4. I don't think I did it, but
Yeah, because so, right, if 60% of this unknown number is 180, it definitely has to be, right, greater than 180. So like, for example, let me see if I can do it. So we know we kind of have, right, a 60-40 split, right? We know that, right, a 60% is 180. Anyone else get an answer or figure out how to do number 5? So when we work with percentages, it's kind of annoying and hard. I don't even think on my scientific calculator, you can see on screen, like I can't even put 60% into anything. So this is our equation, right? So basically what we need to do, right, is divide both sides by 60%. So when we're dealing with percents, it's easiest to convert them into decimals. Does anyone know what 60% is in decimal form? Correct. Okay. So 60% is the same as 0.6, right? Then I just take and divide both sides of my equation by 0.6. So 180 divided by 0.6. So there's 300 total students, right? And we can check that by saying, okay, if there's 300 total students, what's 60% of that? 100. So yeah, when you see percentages, the best thing to do, convert it into decimal. You guys need help or practice on that, we can do a lesson on that. And then, right, just multiply or divide depending on what you have. So if you have the parts, you divide to get the whole. You have the whole, multiply it by the percentage to get the part. Okay. No worries. All right, how about number 6? Jackie cut a ribbon into 8 equal pieces. So hopefully everyone figured out, right? This is telling us to divide by 8, right? if we have 8 equal pieces. She measured and found that each piece was 2 inches longer than a foot-long ruler. So how long is each piece? 14 inches. Did everyone? So that's kind of the second step here. It's not too painful. Did everyone recognize that this was saying, okay, so each piece is 14 inches, and we have 8 total equal pieces of 14-inch ribbon. So what's the length of the original ribbon? 112. How did we get that? Yep, exactly, right? So we have our ribbons, right? Divided by 8 equals 14 inches. And so, right, yep, just multiply both sides by 8. So the original ribbon was 112 inches long. Okay. Good. So word problems definitely going to come into play. And, just like we were talking about with faith, you're probably, sorry. So there are some questions that might ask you like just to do the setup step, like which equation helps you get the answer. But of course, if you don't necessarily need this step to get the solution. Hopefully you guys are seeing that. So good. Okay. Well done, everyone. Let's take a break till about 2:15. Okay. Always need a break in our math time. Okay. So we'll take a break till 2:15 and then we'll get back into our lesson now that we've, I think, done a pretty exhaustive review. If you guys are still feeling lost or confused, definitely let me know. But, we are just reviewing stuff that we've gone through. So, all right, let's take a break. Oh yeah, sorry. I typed 2:15 in the chat because. Yeah, so let's take a break. Okay. I'm lost. Okay. Have you worked on algebra before? No. Okay. Hopefully, yeah. Okay. So we've been working through our basic algebra lesson. Everyone's been doing pretty darn good. So we are up to lesson 7. Okay. We started going through lesson 7 and that's when we kind of decided, I guess we finished lesson 7. Hopefully everyone's feeling good about that. And then let's move on to lesson 8. So it says page 16 down in the bottom left corner. So it's the back of the 9th page if you have the paper copies, which would make it like page 19 or so. If you're looking at the, goodness gracious, I'm so sorry. If you're looking at the digital version. Okay. Does everyone have these materials in one form or another? Do I need to put the link in the chat to this digital version? Okie doke. All right. So the goal is the same when solving any equation. Isolate the variable to find its value. Does everyone understand? I mean, we've done this, so hopefully everyone understands, right? But, right? So here we're saying, right, by itself on one side of right? So hopefully everyone's feeling good about that. Solving for the variable, okay? To solve equations with multiple steps, use the same process you've already learned. Use inverse operations to get the variable by itself on one side of the equation. Okay, that's what we just did, right, when we practiced those 5 equations, okay? Sometimes when you solve an equation, all of the variable terms are eliminated and a number sentence remains. If the number sentence is true, then the equation is true for all real values of x. So basically it's saying x could equal any number, 0 through infinity, and it would work, okay? If the number sentence is false, and we're gonna look at some examples here, then the equation has no real solution. Okay, there's no solution here. You're crazy. Okay. So. Okay, so let's look at our example. So example number 1, we have an equation. Hopefully you guys can see this. I'm gonna zoom in. Okay, so here's our equation. Okay. X plus 6 equals 12 minus 1/2 x. Now, if we look at this equation, how many terms are there in this equation? You guys remember that? Pardon?
5.
I guess if we count the equal sign, yes. If we don't count the equal sign, then we have 4 terms, right? So if, no, so Eddie, we're just looking at the pieces here. It's okay though. So, right, this equation has 4 total terms, right? It has an x, a positive 6, a positive 12, and a negative 1/2 x. When we look at these 4 terms, are there any like terms?
The 6 and the 12.
Okay, are there any other like terms?
No.
So is x and 1/2 and negative 1/2 x, those aren't like terms?
No.
Really? Did you
Well, it's
guys-
because I
Yeah, exactly. So guys, remember, and it's okay because I forgot that we had done this a little bit, so don't worry too much, right? So yes, right, our coefficients or our kind of our whole numbers without variables are like terms, but our x and our 1/2 x are like terms, okay? So of course, right, if our goal is to get x by itself on one side of the equal sign. So now, right, we have to figure out like, oh my gosh, right? We've got x's on both sides. So we need to combine like terms before we can do any of our solving steps, like subtracting 6 from both sides, multiplying or dividing. Okay, so that's what it's telling us here, right? Get the variable terms on one side of the equation and the constant terms on the other side. Okay, so, right, if we're subtracting 1/2 x here, right, to get rid of that, we're going to add 1/2 x. And since we're doing that to one side of the equation, we have to do it to the other side. Okay, does that make sense? So, right, that the minus 1/2 x and the positive 1/2 x cancel, and we're just left with 12 on this side of the equation. X plus 1/2 x, right, equals 3/2 x. And our plus 6 we just bring down. Okay. So this is the first thing that I want us to notice, right, is that if there are variables, right, on both sides of the equal sign, we have to combine those terms before we can solve the equation. Okay? Does everyone understand this step and feel like you can do it? Maybe? Okay. Does everyone understand how we get from this step to this step? Because this is what we've already been working on, right? 3/2 x plus 6 equals 12. Then we just subtract 6 from both sides, right? And then we take the reciprocal 2/3 and right multiply. So we get our answer of 4. Okay. Does that make sense? Hopefully. Okay. So like I said, so we're just adding this extra first step. Once you get here, right, once you've got all of your variables on one side of the equation, then you're just solving like normal, okay? So in example 2 is what we see down here. Oh, sorry guys. Right, where it says like sometimes all of the variables are eliminated. So let's look at that. Okay, so we start with the equation here. Okay. Right, lots of terms to combine, right? First, we have to distribute -2 through our parentheses to simplify that piece. So that's how we get from here to here. Okay. Does everyone see that step? So now I have to combine these two like terms first. 0.7n minus 0.8n is -0.1n. Since I have -0.1n on both sides, right? If I add to both sides, my n term goes away. Do you guys see that? So that then I'm left with -10 equals -10. So the answer to this question is then, right? N can be any number and it will basically work out. How does example 2 seem? Okay. So example 3, we'll get the opposite situation. So once again, right, start here by distributing my 1/4 here. 1/4 of 8b is 2b, 1/4 of 12 is 3. As you can see, right, I've got positive 2b on both sides of my equation. So if I subtract 2b from both sides, I'm left with 2 equals 3, which is not true. Therefore, this problem has no solution, right? There's no number that we can put into b that makes this true, okay? So does examples 2 and 3 make sense, what they're trying to show? Because you might have a problem like this. I'm trying to remember if I've seen, I don't feel like I've seen a practice question, but I don't want to trust myself completely. So remember that sometimes your variable terms might cancel out and you're left with just numbers. If it's, you know, something equals itself, then our variable can be any number. If it's an untrue statement like 2 equals 3, then we know that it's basically there's no solution, right? So it's like, you gave me one that doesn't work. How dare you? Okay. All right, then let's look at All right. How's everyone feeling? So let's look at the practice questions on the next page. Okay. And let's work on number 1 together. All right, so we've got 0.3 times the quantity 3x plus 12 equals 0.9x plus 4. Okay, so of course, right, my first step is to distribute, right, my 3 through here. So I think this is gonna be 0.9, right? 0.3 times 3, yeah. Okay, so we got 0.3 times 3 gives me 0.9x plus 3.536, sorry, 3.6, right? 0.3 times 12. Okay, equals 0.9x plus 4. Okay, so of course, right, we've got 4 terms. Hopefully everyone can see the 4 terms. These are like terms. So of course I want to combine them. So I need to write subtract 0.9x from both sides, but right, that cancels. So I'm left with 3.6 equals 4. Is this true? Is 3.6 equal 4? So, right, so what does it mean if I have an untrue statement? Yep. Okay, does everyone see how that works, hopefully? Like I said, slow me down, stop me with questions. Okay, but if our variables, hopefully everyone sees how these cancel. And what I'm left over with is not true statement. So we know that at least for this equation, right, there's no solution, no number that we can put in for x that will make this work evenly. Okay. So for number 1, we've got B. Okay. Go ahead and try to see A, B, and C. Okay. Try those 3 and then we'll talk about it. Okay.
We're on lesson 8, right?
Yeah, we're on lesson 8, so this is page 17 down in the bottom right corner. Does that make sense, Luba?
Yeah,
Um,
but I have 16 at the bottom of mine. I'm
Okay.
like thoroughly confused. I'm like, all right, I must have mixed up my papers.
yeah, this is the front page. You have this, right?
Yes.
And it's about the front of the 10th page. You guys got your answers? Okay. All right, let's. All right, so once again, hopefully everyone's feeling good about your terms, right? We have an 8x, 9, a 33, and a negative 4x, okay? And so of course, my first step is to, once I've kind of seen my terms, then I see that, right, I have like terms on either side of my equal sign, so I need to combine them, okay? When deciding when to combine, or like which to combine with what, I always kind of focus on the smaller number because it's easier to subtract, but here we're adding, well, and then also, right, if it's a negative number, it's also kind of the one that I would choose to work with to combine my like terms, just because adding is easier than subtracting. So of course, we're going to add 4x both sides of the equation, right? Minus 4x plus 4x is 0. 8x plus 4x is 12x. Right, and then just everything else comes down. Okay. And then we're gonna subtract 9 from both sides. And x equals 2. You guys get that one? Awesome. All right. So 2b, right? So even though we have to deal with fractions here, right? So here's where I was kind of talking about, right? And, you know, here, right, the -4 was kind of the easy term to deal with. Here, both of my x terms are positive, so I'm going to choose the smaller. So I'm going to subtract 2/3 from both sides. 5/3 minus 2/3 is 3/3 or 1, right? Or no, I'm sorry. 5/3 minus 1/3 is 4/3, sorry. Goodness gracious, 5/3 minus 1/3. So, right, so now if I combine my terms like that, I end up with 5 equals 2/3 x plus 21. Sorry. Okay. So subtract 21 from both sides. So now I have -16 equals 2/3 x. So remember to get rid of our fraction that's being multiplied, right? We use the reciprocal. So 3/2. So I can take a 2 out of here and a 2 out of here. These cancel. So x equals -24. You guys get that one? Does it make sense at least, hopefully?
I don't make sense of it.
Okay, just a second. All right. So if we look at here, right, we've got 4 terms. Okay. Right, and my 1/3 x term and my 5/3 x term, because they're on opposite sides of the equal sign, I need to combine them before I can solve the equation for x. So what I did here was I subtracted 1/3 x from both sides of the equation. Okay, when I subtract 1/3 minus, or well, if I have 1/3 x minus 1/3 x, that's 0, right? So I just have my 5 left over on this side of the equal sign. 5/3 minus 1/3 gives me 2/3, right? Because I have to subtract 1/3 from both sides. So when I combine 5/3 x minus 1/3 x, I'm left with 2/3. Oh, shoot, this should be a 4. I'm so sorry, guys. Goodness gracious. What my deal is today. Okay, thank you, Liz, or whomever that was. Goodness. Did I tell you guys I'm not a math teacher? I'm not, just so you know. I just play one on TV. So then if we have 4/3 down here, it doesn't make that much of a difference, but. So actually, sorry, it should be -12 is the answer. Is that your answer, Liz? And I totally just can't subtract, or do I need to walk through it again?
If you could walk through it, because I got confused.
Yeah, I know, and this is why okay. So you see the 4 terms, right? So of course, if we have terms like terms with variables on either side of the equal sign, I have to do something to combine them, okay? So here, because 1/3 is smaller and I'm gonna have to subtract it, I'm gonna subtract 1/3 x from both sides of the equation, okay? So once again, right? 1/3 x minus 1/3 x is 0, right? So that cancels out the 1/3 x on this side. And I just have my 5 left over. Okay. Does that set feel all right?
Yes.
Okay, so then because I subtracted 1/3 on this side, I have to subtract 1/3 on this side. When I subtract 5/3 x minus 1/3 x, I get 4/3 x. Does that make sense?
Yes.
So I combine my like terms, so now I have an equation I can solve, right? 5 equals 4/3 x plus 21. So then I just, now that my terms are combined, I can just solve for x, right? I can subtract 21 from both sides of the equation. When I do that, right, plus 5 minus 21 gives me negative 16. Okay. And
Okay.
then, 2/3 x on this side, or 4/3 x on this side. So then I have, right, negative 16 equals 4/3 x. So to undo my fraction, I take the reciprocal of it and multiply both sides by 3/4. Okay, so of course here, 3/4 times 4/3 cancels down to 1, so I'm left with just an x. 4/3 times 16 is, or sorry, 4/3 times negative 16 is -4. Or -12, sorry. Any better?
I just don't know where you go from the -16 and then get -12. So
Okay.
you're 4.
So
Okay,
when
so
I,
you're minus, are you minusing the 4 from the 16?
no,
Okay.
I'm reducing it. So remember that once I subtract my 21 from both sides, then I'm left with -16 equals 4/3 x. Okay. So, right, so in order to get x by itself, I need to multiply both sides of the equation by 3/4. Okay. So of course here, right, 3/4 times 4/3 is 1. So I'm left with x on this side. Okay. So then I'm doing that cross reducing step, Liz, in order to make my calculations easier, right? So, right, if I look here, I have a 4, and here I have a -16, so I can take a 4 out of here and a 4 out of here. If I take a 4 out of here, I have 1. If I take a 4 out of here, I have -4. 3 times -4 is -12. And 1 times 1 is 1. So that was that. It was that cross reducing step that I was doing to help me get here.
Okay.
Otherwise, right, you can do 3 times 16 divided by 4, and you get 12 as well. Right, so you can just multiply across the top and bottom. But the cross reducing just kind of makes the calculation easier to do in your head. So, good.
Yes.
All right, thanks for bearing with me. I'm sorry. Like I said, I'm gonna become a math teacher one day. A real one. Maybe if I believe hard enough. Okay. All right, good. So finally, we've got this one. Let's see, 2.2 times 3 is 6.6, right? So once again, before I can combine my like terms, I have to get rid of these parentheses by using the distributive property, right? And I'm going to multiply each of the terms inside by my term outside. So I've got 2.2x plus 6.6 equals 8x plus 3.7. Okay. So once again, right, I'm looking for like terms, make sure all of my like terms are combined. So similarly, right, when I'm trying to decide how to combine these terms, I'm always going to take the smaller, right, and subtract it from the larger. So let's subtract 2.2x from both sides. So 8 minus 2.2. So I probably shouldn't try and do any more mental math here. Equals 5.8x plus 3.7. Okay. So then, right, subtract 3.7 from both sides, so 6.6. Only I could. 3.7. Really weird. Okay, so then 2.9 equals 5.8x. So then let's just divide both sides by that. Really weird. Okay. So x equals 0.5. Okay, because I divide both sides by 5 point. All right, how's everyone feeling? All right, go ahead and work through the remaining problems 3 through 7 on this page. Okay. And just see how much you can get through in the last 10 minutes of class here. And then we'll get going from there. All right, so we'll go ahead and go over the remaining practice problems on Wednesday. So if you didn't get them finished before the end of class, try to have them prepared for Wednesday's class, okay? You guys are doing really nicely. Let me know if we need to go faster, slower, if we need to practice or review more. But you guys seem to be doing well, so cool. Any other questions or concerns before we're all the way finished? So there is study hall at 4 o'clock today, either in person or on Zoom. So if you have something like math that you need a little extra help and with the teacher, Daniel is available either in this room or on Zoom, like I said. So definitely, if you have the time, worth the effort to kind of continue practice. It's working time. So cool. Good to go. All righty. Thank you guys. Have a wonderful rest of your day. Hopefully we'll be on the drive. Bye. Thank you.
You want your temp, your.
Yeah, if you don't need it. Is your bus pass still active, Eddie?
It expired.
Okay, do you need a new one?
Yeah.
Okay, do you have time to fill out your form now, or do you want to do that later?
I can go ahead.
Let me see if I can find it here. You folks on Zoom good? Any questions before we're done today? Thank you guys. See ya.